Right. Good morning to all. Am I audible? Am I audible?
Yes, sir.
Okay. Okay.
Sir,
Yes, please. Right. So let us start today one new topic, which is this is unit number 3. So which comes up as single phase AC circuits. Single phase AC circuits. Alright. So in this unit, we deal about the AC circuits, which is of nature with the single phase. We have generally in AC circuits three phase and single phase both are available, in which we see single phase AC circuits. And in AC system, first let me give you the DC, and let me brought to the AC system from the DC system. And what is the DC system? Previously we stated that any quantity that may be voltage or current, if it is constant with respect to time, if it is constant with respect to time as like this, then see, whatever may be the time, whether it is 1 second, 2 seconds, 3 seconds or 4 seconds, the current remains constant. So what is current? Current is rate of change of the charge dq by dt. That means if the rate of change of the charge is constant, we can call that as a DC system. Now, if we have any variable quantity instead of constant, like if this rate of change of the charge is varying with respect to time, such quantities we call as a AC. So, for example, as like this, if I'll take some waveform in this way, let me take two axes for everything. So you can consider either voltage or current. So in generally, I will consider as f of t. This f of t is a function. This may be voltage or it may be current. And this x-axis I will be considering as a time. So now see that if I have a function which is having a constant value, let me take color. If it has a constant value as like this for certain time duration, how long it is constant? Up to this instant, let us say 0 to this t, some time instant. Let me tell you, this is some t1. Then after t1, if it changes something like this, suddenly it is dropping down to negative value, and from negative value it will constant for some more time. So like this the pattern will be repeated. Again, it is jumping suddenly towards the positive and remains constant like this. Now, could you observe that the magnitude of the function f of t, this may be, let me tell you that this may be a voltage function or current function. Let us talk about the current. If the current is constant for this time interval, then after this t1 interval, suddenly it is changing. Means could you see that there is a change in the current after, means at the instant of t1. Similarly, at some other instant t2, again it is suddenly changing from negative to positive. Here if it is, let us say for example 2 amperes, and suddenly at t1 instant it is going to minus 2 amperes, minus 2 amperes. and at T2 instant suddenly it is going to plus 2 amperes. This is what the change. It is not constant. Though it is constant from 0 to T1, but at T1 it suddenly changes. So this kind of waveform can be called as a AC, alternating current waveform. So alternatively it is changing. Try to see that this entire thing is positive. Suddenly it is changing to negative. That is what the alternative. Then again suddenly changing to the positive alternatively. So this is one kind of AC waveform. Similarly, let me introduce some more waveforms. Then I will try to characterize these waveforms more detail. So now let me take one more waveform which has the nature of alternating. So see that if the voltage or current function, let me take in generally f of t, and let us say this f of t is current now. And this is the time axis t. Now assume that the current is rising slowly as like this, slowly. How long? It is reaching to, let us say, some 2 amperes. As long as it reached to 2 amperes, it is rising. Then suddenly it going to be fall down. To where? To 0. Then again it is slowly rising back to the 2 amperes. And again suddenly falling down to 0. And rising, falling down to 0. And so on. Like this kind of things will be repeated. Now try to see that. So it is not alternatively changing between positive and negative, but still it has a varying nature. What is varying? Current is changing. How? See that at 0 instant the current is 0 amperes. At some this corresponding T1 instant the current is, let us say, 1 ampere. Then at T2 instant the current is suddenly, means from 2 amperes to 0 it is falling down, and so on. Like that, again it is rising and falling down, rising and falling down. So nowhere it is constant, it is continuously changing. This also can be called as a AC waveform. And like this, so let me introduce some more waveforms. So some more waveforms. Oh, okay. So let me introduce some more waveforms. What happened? Okay. Right. So let me take one more kind of AC kind of waveform, and like this time axis. This may be f of t, which may be voltage or current. As of now I am taking the current. Now see that, so the same pattern but little bit different way. It is slowly rising and suddenly falling down to negative, falling down to negative. So let me not to bring so much, yeah, here up to here. Then again rising towards positive and falling down to negative, and rising towards positive, falling down to negative, and so on. It will keep on repeats. Now see that here, along with changing amplitudes, the polarity also going to change. See here, this is positive, this is negative. Again positive, negative. So like this, its polarity also changing. So AC means it is not only changing in the polarity, it may change only in the amplitude also, as like this. See, all are positive. This is positive, this is positive, this is positive. Okay? So ultimately alternating current means it may change the polarity from positive to negative with constant amplitude. So see here, as long as it is in the positive it is a 2 amperes, but only polarity changing again constant. So as because this is 2 amperes constant, you cannot call this as a DC, as because polarity has changed. Something is changed. That may be polarity or amplitude or together both. So I'll show one more waveform. So see here, it is changing the amplitude, it is changing the polarity also. So this kind of waveforms can also be called as a AC waveforms. And let me introduce one more alternating waveform which is very interesting, and majorly we will be focusing on this waveform. So most of the times. So let us say f of t is equal to again current waveform, and the nature of the variation of that waveform is as like sine function, very smooth function, as like this, and it is going back to positive and negative continuously alternatively. So I should draw this very smoothly, but so let me put, oh, sorry. So like this, a smooth waveform. So one should draw and so on. Now see that how the function I of t is changing very nicely, like step by step, one value after the other. It is rising to a value of maximum value of Im. Then it is falling down, slowly decreasing towards the zero and slowly rising towards the negative value. This is what minus Im and so on. So this pattern going to be repeated. See here it is positive, in this duration it is negative, again positive and negative. So this pattern going to be repeated. So if you observe these waveforms and try to observe, first try to understand in a better way that AC means so it it has it has varying amplitudes amplitudes or even and change in change in direction. Direction means from positive to negative or negative to positive. So let me write in bracket. So as like this, positive to negative and negative to positive. Okay. So this is in general way that AC means it has varying amplitudes or it may have additionally change in direction also, or it may have only change in direction as like this. See here first waveform, only change in direction but amplitudes are constant. Okay. So once it changed from positive to negative, still it is 2 amperes but negative amperes. So that you should understand in a better way. Okay. So these are what the AC waveforms, how does it look like? Means it is having a variation in the amplitude and change in the direction also. Okay? Right. So now let me introduce the one more important characteristics of these. So
Sir,
yes, yes, please. Yes.
sir, అంటే ఇప్పుడు ఏసీ కరెంట్లీ హ్యావింగ్ ఓన్లీ వేరియస్ డైరెక్షన్స్, అదే డీసీ అయితే ఓన్లీ హ్యావింగ్ వన్ డైరెక్షనా సార్?
Yes, like this constant, so it may have any value but it remains constant. For example, as like this also we can call as a DC. See here, so this is a time t, if this is current I, so I may have current of negative 10 amperes, but see irrespective of the time, at any instant of time current is minus 10 only, it doesn't change, it will continue like that. This is what the DC. It may be positive, this is zero level, so it may be negative, that doesn't matter, but it remains same value over a entire time duration. Clear?
ఎస్
సార్
సార్.
Yes.
అక్కడ ఏసీ సర్క్యూట్ లో ఫస్ట్ ఎగ్జాంపుల్ గ్రాఫ్ లో T1 వాల్యూ పాజిటివ్ 2 amperes సార్, నెగిటివ్ 2 amperes సార్.
This one, right?
ఎస్ సార్, ఆ
Yeah.
గ్రాఫ్.
Yeah. So this is 2 amperes, some value. For example, I took some value. So this may be 2 amperes, and once it suddenly changes, then it go to the negative 2 amperes.
అంటే ఈ గ్రాఫ్ ని బట్టి కరెక్ట్ గా T1 వాల్యూ చెప్పలేము సార్.
I will give you later on what are the T1 values, T2 values, just to demonstrate that 0 to T1, 0 to T1 amplitude is amplitude is 2 amperes. Okay, and T1 to T2, the amplitude is minus 2 amperes. See? So just to demonstrate this, I had given the indication that what is T1, what is T2. This is the instant at which the current is changing suddenly from plus 2 to minus 2. This is the instant at which the current is changing from minus 2 to plus 2. Is this clear? Later on I will give you exact values of what is T1, what is T2. You no need to determine what is T1. Okay, they will give you. It is known. Okay.
Okay, sir.
Okay, right. Right. Now let us see one more important point, which is characteristics of characteristics of periodic functions. Periodic functions. Characteristics of periodic functions. Now see that whatever waveforms I had taken here, let me copy once again. So these things, and now try to understand what is mean by periodic functions. Right. Now see here how this alternating waveform is continuing. How this alternative waveform is continuing. See that from 0 to T1 it is having an amplitude of 2 amperes. Then T1 to T2 it is having an amplitude of minus 2 amperes. Then after T2, like let us say T2 to some more time interval, one more time interval, which is let us say this one as T3, T3, and this is time axis. So what will be the amplitude between T2 to T3? Tell me, how much is that? 2 amperes. Clear? Now try to observe after T2 interval. So whatever coming is a repetition of the previous intervals. Again, the same thing going to be repeated. So T3 to let us say T4. So you will get minus 2 amperes. Then after this interval, again first cycle means first nature going to be repeated. What is the nature? Over a time interval 2 amperes, next time interval minus 2 amperes. Like that, this pattern going to be repeated. So this repetition of certain pattern regularly after certain time period is called the periodic waveforms or periodic functions. So just try to understand what is mean by periodic functions. Means for every certain time interval, regularly it going to be repeated. For every certain time interval, the function, let me write this statement that what is mean by periodic functions means, so which repeats, regularly, regularly, regularly after a certain time after a certain time time so this certain time we call as time period. Now try to identify what is the time period of this periodic waveform. This is going to be repeated. Okay, so now try to observe 0 to T1 2 amperes, T1 to T2 minus 2 amperes. Then after this entire time interval, what is the time interval for this entire thing? 0 to tell 0 to T2. Then after 0 to T2, then next same kind of nature is going to be repeated in the next time interval. So this identification that what is the interval at which the waveform is repeating regularly is called as the time period. So now try to identify that 0 to T1 positive, T1 to T2 negative, then from T2 onwards again same nature going to be repeated. This one, let me tell you. So this nature going to be repeated again. So this is, let us say, negative, and this copy is repeating over here. See here, this is again same as this previous one, and next what I will get is this negative as like this. So this is going to be keep on repeating. This green, red, green, red, green, red going to be keep on repeating. Now try to observe for what time interval of pattern is repeating again and again. Green, red pattern is going to be repeated. How much duration does it occupy? 0 to T2 instant it is occupying. From T2 onwards again same previous pattern is repeating. So this corresponding time interval we call as the time period T. Usually we represent capital T for the time period, where this T is called as time period. Now in the same way try to identify for the next waveform, what is the time period? What is the time period?
0 to T1, sir.
No, not 0 to T1. If it is 0 to T1, as what you said is 0 to T1, for example, how much is 0 to T1 amplitude? It is changing from 0 amperes, 0 amperes to 1 ampere. Now, in the immediate next time interval, that is what T1 to T2, some resound is coming. Can you switch off your mic? So, am I getting T1 to T2 again 0 to 1 ampere? Am I getting again 0?
Minus 1.
No, I am not getting. What I am getting is 1 to 2 amperes I am getting here. 1 to 2 amperes. Then if I will see after T2, now see here, T2, let me say here some if you want is one more instant, T3 and T4 etc. It's your wish. You can split as many intervals as you want, no issue. So let us say T2 to T3. T3 is corresponding to 1 ampere, let us say again. So how much is that? 0 to 1 ampere. Then T3 to T4. 1 ampere to 2 ampere. That means now just it is a generalized thing that what shape is repeating? Tell me. What shape is repeating? Yes, triangular shape
Triangle.
is repeating. That's all. Then how much is the time period occupied by that triangular shape? That is what the time period. Clear? So let me tell you that this is the pattern uh, which is repeating. A triangular shape pattern is repeating again in the next time interval. This is what the triangular shape pattern. Again same triangular shape pattern is going to be repeated. Now how much is the time duration occupied by this triangular shape? That is what the time period. So now tell me how much is the time period? T.
0 to T2, sir.
Exactly. So we can directly write T2 minus 0 is what the duration. So we can write T2 T is equal to T2. Capital T. Capital T means time period. Clear? Right. So similarly, you can identify the time period for remaining two waveforms also. So let me take these two waveforms. Quickly identify the time period for these two waveforms also, so that we will have a better understanding on this. So which will be very much helpful for remaining entire AC discussions. So this is 0. Now see that what is the nature of the pattern? See one triangle which is in the positive direction. Okay. One more triangle which is in the negative direction. Then try to observe this positive and negative combination is going to be repeated. Yes or no? See what is the
Yes, sir.
next time interval? Again positive triangle, then negative triangle.
Negative triangle.
So this combination is repeating, that you should understand. Now, how much is the time duration for this combination? Is this entire thing. So up to this position. So up to this
Positive
position,
and negative triangle, sir.
yes, positive and negative triangle together is called one time period. One time period. Clear? So next time period is this one again. How much is this duration means same as like the first. This is also T. Right. Next, let us identify the next waveform and see that for this waveform, you will have one positive region. This is what the positive region, and this is what the negative region, and these shapes are going to be repeated in the next consequent duration of the time as like this. See here. Now, can you identify what pattern is repeating? Positive and negative pattern is repeating. So, together, this positive and negative pattern we call one time period. One time period. Now, apart from this, you should understand that. So, so try to see here, it has a certain amplitude. Amplitude means value. So, here, this 2 amperes is referred as the amplitude. So this amplitude may be positive or negative. So this also can be referred as a amplitude. And here how much is the, see, try to observe one more thing. This maximum value, here you can see that amplitude is varying. From where? From 0 to 2 amperes. Then is there any rise beyond the 2 amperes? No. So this 2 amperes can be called as a peak amplitude. Peak amplitude. Peak amplitude. That means that is the maximum value. But still we may have lesser values like 1 ampere, zero point 0.5 amperes, 1.5 amperes, etc. It doesn't matter, but we are very much interested most of the times as peak amplitudes. Clear? Sometimes we may not write more specifically as peak amplitudes, directly we may say as amplitude. You should understand that it is the peak amplitude. Clear? And see in the same way here how much is the amplitude. This one is some, let us say 2 amperes, and this one is minus 2 amperes. So these are referred as amplitudes. This is positive amplitude, and this is negative amplitude. Now, difference between positive to negative amplitude we call as peak to peak amplitude. Peak to peak amplitude. How much is this peak to peak amplitude? Can you tell me? This is equal to positive peak amplitude is 2 minus of negative peak amplitude is minus 2. So this is what the peak to peak amplitude 2 plus 2 is what the 4 amperes will be referred as peak to peak amplitude, means positive peak to negative peak. How much is the height? That height itself we call as a peak to peak amplitude. Here to here, this height, length, we call as a peak to peak amplitude. And if you observe here, the peak to peak amplitude means only one peak is there which is of positive. Then positive to what is the lesser value? Lesser value is only the zero value. There is no negative peak. So you should say that peak amplitude itself is the peak to peak amplitude. Okay. So next, here you can see that how much is the peak to peak amplitude? 2 minus of minus 2. This is what the 4 amperes. Peak to peak amplitude is 4 amperes. And let us finally see this one. So how much is this peak to peak amplitude? Positive amplitude is Im. In generally I am dealing now. So positive amplitude is Im and negative amplitude is minus Im. So the difference from positive to negative is what? The peak to peak amplitude we usually write in the suffix form as I suffix p to p, means peak to peak is equal to Im minus of Im, which is equal to 2Im. See? Right. So now, in generally, for these periodic functions, how we identify is that mathematically, 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 we write in this way that, so if the function f of t is having same value as like at the instant of t plus t. Just let me describe this relationship which obeys this property we can call as a periodic functions where this time interval is minus infinite to plus infinite, any value. T can be any value. Now try to see that if I'll assume, so here let us take, if I'll assume at this instant 1 ampere, at this instant 1 ampere. What is that instant? T1 instant. Now what I'll say is that f of T1, f of T1. Then after how much time interval I am getting again same f of T1 value. What is the f of T1? 1 ampere. 1 ampere. Now see that after T1, if I'll add for the T1 capital T, how much it move? If I'll add for T1 capital T, how much it does move forward? Is it moves by this red triangle and it will reach over here. This is what T1 plus T. T1 plus T. That means after time interval of T, capital T, again it is producing same value. How much is that value? 1 ampere. So you can see here T plus capital T is also 1 ampere. That is what the periodic function meaning. If you want, you can see in simple manner in this way. See here, at 0 how much is the amplitude? 0. Then after T interval how much is the amplitude? 0. That is what at 0, that is what f of t plus 0 here. Then at t plus capital T also 0. So that is what the mathematically we inspect a function whether it is periodic or not in this way, that f of t is equal to f of t plus t, which obeys this kind of property is called as a periodic functions. Periodic functions. That means after time interval of t, it must have same values as like the previous interval. Okay. Now you can see here at, let us say at this instant, how much is the value? Im. Then if I'll add t time for this interval, where does it reach? It reach to the next peak. Is these peaks both are same or not? Yes, same. So the time period can be chosen in many ways. The time period can be taken from 0 to again 0 this 0, or peak to next positive peak, positive peak to positive peak, or I can also consider time period from negative peak to negative peak. All these time intervals are t only. Clear? You can consider 0 to 0, that is what the time period which we previously described. You can consider positive peak to negative peak. You can also consider, positive peak to positive peak. You can also consider negative peak to negative peak. All these will represent the time period. That means after this much of time interval, waveform values are matching with the previous cycle values. That is what mathematically f of t is equal to f of t plus capital T. F of t plus capital T.